Say hi from Cherish Math. This is the problem here for today. A semicircle is inscribed in a triangle as shown here. Find the length of its radius. There are two types of solutions to this problem. Let me show for the first method here. According to this diagram, ABC, the triangle, and inscribed here is a semicircle. I know that for this triangle is an isosceles triangle. So the angle here is theta. So width for the part on the right side here as well. The length BC is same as 10 units. And I'm going to label here as angle alpha. And now I'm going to use the cosine rule to find what is the value of alpha angle. That will be 12 square equal 10 square plus 10 square minus 2 times 10 times 10 cos alpha. For cos alpha, it is 200 minus 144 divided by 200. And now the alpha is same as inverse of the cos, and by simplifying this fraction it is now 0.28. I remain in such a form for the next calculation. In the next step, I'm going to make a line connecting from the point of O, which is the center of the semicircle, to the point of tangent for the line BC, which I am pointing here. And this serves as the radius. I can confirm that for this part, it is a right angle because of the BC line is tangent to the circle. And for the OB is half of the 12. I'm going to label it as 6 units. Now, for the sine, theta is going to be opposite with the radius of R divided by 6 units of this OB. Let me work out the radius now is 6 multiplied with the sine theta. Now, the crucial part here is rely on the theta angle. And how am I going to get it? Theta is simply by using the supplementary angles of this triangle ABC. So I'm going to use 180 degrees minus alpha divided by 2. And what is the value of alpha? I have to substitute from here. It is 180 degrees minus inverse of the cos 0.28 divided by 2. And I have to substitute the value of the theta into this sine theta. And that turns R is 6 multiplied with sine. I'm going to copy and paste into it. And the value of this radius that I'm going to get here is by using calculator, which is 4.8 units. And we solve it. Here comes our second method to solve the problem by using a different way of doing it. And I have to explain all over. Now, according to this triangle ABC, I know that this is an isosceles triangle. So for the side BC, it is the same with 10 units. So I'm going to label 10 for the BC. And OB is 1/2 of the 12. That is 6 units. And now I'm going to produce a line connecting from O to this tangent of the line BC. And I'm going to label here as D. and this serves as OD for the radius of the circle. And in our case here, it is the semicircle. Let me connect a line from O to C, and this OC, I know that it is with the 8th unit of the height, and I got it simply by using the theorem Pythagoras, and that is by using the tan as the hypotenuse, square it up, add up with the square of 6, and I squared the whole thing. So OC is in fact 8 units. I'm here to confirm that for this is at a right angle because BC is a tangent to the semicircle, and for this part 2 is at a right angle. Now I'm going to try to use the similarity to solve the problem here, which it is a rather easy method compared to the first one. The line BC is similar to OC. So now the scale factor that I am going to get it here is by using the tan divided by 8. Tan is BC and 8 is OC. So these two lines are similar. And the same scale factor happens to OB, which is similar to the radius of the R. And that would be by using 6 divided by the R, or the radius. And by rearrange these things, cross multiply the values, and I'm going to get here is 4.8. And we solve the puzzle. Thanks for watching, and please subscribe.